the lesson that I'm doing is 4.0a.4. Now, the students, I will give an I can statement to repeat, but for this video, we will find all factor pairs for a whole number in the range 1 through 100. Recognize that a whole number is a multiple of each of its factors. Determine whether a given whole number in the range of 1 to 100 is a multiple of a given one-digit number. Determine whether a given whole number in the range of 1 to 100 is prime or composite. To my students, I will say, I can find factor pairs for numbers to 100 and use factors to identify prime and composite numbers. Let's review some of the vocabulary words you will see that we will add to our math wall. Factor, product, prime, composite, and array. A factor is a number or quantity that when multiplied with another produces a given number. The product is a quantity obtained by multiplying quantities together, and it is the answer. 1 times 10 equals 10. 1 is a factor, 10 is a factor, 10 is the product. The two factors, 2 times 5, the product is 10. The product is 10. It is the answer to a multiplication problem. The factors of 10 are numbers that can be multiplied to make 10. A prime number is a whole number greater than 1, whose only two whole number factors are 1 and itself. Here are some prime numbers: 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. Composite number is a whole number that can be evenly divided by numbers other than 1 or itself. 9 can be divided evenly by 3. 4 can be divided evenly by 2. An array. Array is an ordered series of arrangement. Here is a perfect array here. You have 3 rows, 1, 2, 3, and 5 stars per row. So it's 3 times 5. 3 times 5 equals 15. These are the arrays. Now, I'm going to show you 6 randomly placed cubes. 6 randomly placed cubes. Six. The students will take out their own cubes that they have in little plastic bags. Each one of them have their own amount. We're going to make a rectangle using the cubes. So I'll give students a chance to play around with the cubes and try to make as many rectangles as they can. Now, what I see is a common one that the students are doing is 1, 2, 3, 1, 2, 3. So I will show them that it's 2 rows and it's 3 in each row. So 3 times 2 equals 6. Another student did 1 row and they did 1, 2, 3, 4, 5, 6. 6 in a row. Actually, this is 3 and there are 2 rows. So 1 times 6 equals 6. What are the factors? Student would say 2 and 3. Then another student would raise their hand and say 1 and 6. So let's write those out. 1, 2, 3, and 6. Let's make a few more arrays with larger numbers. So now they have 16 cubes Their bags each have about 24 cubes in it because the whole point is for them to play around with the cubes and not to have too many, but just enough to make many numbers of arrays as the numbers change. So now here's one row of 1, 2, 3. This is 16. So there's one row and there are 16 cubes. So there's another row that a student made, and this one has 2 rows and there are 8 each in it. And the last one, there should be more. Here is 4 rows and 4 in each. Now let's write this out. 1 times 16 equals 16. 2 times 8 equals 16. 4 times 4 equals 16. What product is shown on all of the arrays? So we wrote out all of the addition, all of the multiplication problems. 1 times 16, 2 times 8. And then we're going to circle the factors. Circle all the factors from the least to the greatest. Then we're going to write them 1, 2, 8, and 16. Now they're going to turn to their partner and they're going to look for another factor. So the student said 4 and 4. So now I already wrote out the 4 and the 4. So we circle the factors and then we add that in. 1, 2, 4, 8, and 16. When you multiply, the factors are given and you solve the product, which is the answer. In division, you are given the quotient, which is the answer, one factor, and you solve for the other factor. Now we're going to write a problem on the board. The number of bikes is 4 times the number of skateboards in the neighborhood. If there are 8,824 bikes, how many skateboards are there? How many bikes and skateboards are there all together? We are building the problem with the information we are given. The bike is 4 times the skateboard. We're going to use the scientific notation to solve the problem. To answer the last part, the final answer needs to be added together. Now, the S stands for the skateboard and the B stands for the bike. So here is S and here is the bike. Usually it should be about the same amount, the same size. So we're going to say for S, which is the skateboard, we're solving for A. That's an A. And then this is 4 times the amount. So that's 8,824. 824. So there are 4 units equal 8,824. 1 unit equals 8,824 divided by 4. In order to solve this, we're going to use the scientific method, which is to stretch out the problem. We're going to take the 8,824 and we're going to make it 8,000 plus 800 plus 20 plus 4. And we're going to divide it by 4. So 4 goes into 8,000 2,000 times. 4 goes into 800 200 times. 4 goes into 20. Now this will be easy for the students. Will be 5. And 4 goes into 4 one time. So the final would be 2,206. Now, in order to solve for the last part, you need to, how many bikes and skateboards are there altogether? You will add the numbers together. You will add this number with the other total number. When writing the problem out on the whiteboard at the same time as being solved, the students are writing it as we go. They're solving it at the same time. Let's look at prime and composite numbers. What are the factors of 2 times 6? Let me just wipe this off. 2 times 6 equals 12. What are the factors? 2 and 6. What other multiplication sentences can you come up with using different factors that equal 12? And the students will answer 3 times 4, 1 times 12. What are all the factors of 12? Let's write them out. 1, 2, 3, 4, 6, and 12. What are the factors of 1 times 7? Let's look at it. 1 times 7. What are the factors? 1 and 7. Find another factor pair for 7. The students will try to figure it out, and they can't come up with it. That is the same factor. They can say it like this, 7 times 1. But it's the same numbers, just switched around. 7 is a prime number. This is a prime number. Can you think of any other prime numbers? Student will say 5. So 1 times 5 equals 5. And the only other way is 5 times 1 equals 5, but it's the same numbers. There are factor sheets in the middle of your table that I want you to work on with a partner at your table. Students will work with a partner, then by group we will go over some of the problems together. I will use cold calls for some students and have other students repeat the correct way of doing the problem. Students who finish early will draw arrays in their notebooks for each problem. They will circle all the numbers, the prime numbers they can find on their sheet with a colored pencil. On a sheet of scrap paper, they will write out 3 new problems and place it in a stack in the front of the class for other students to use when they're finished. Students will receive an exit ticket, which they will work on independently. Thank you so much, and I look forward to your feedback.